The third and final form of quadratic functions that we're going to talk about in graph is called standard form. And standard form looks like this: y equals ax squared plus bx plus c. And just like with intercept form and vertex form, there's different information that you can gather from standard form that is not as easily gathered in the other two forms. One of those things that we need to figure out is called the axis of symmetry. We've done that before. The equation to figure out the axis of symmetry is x equals negative b over 2a. So in vertex form, we could just look at the x-coordinate of the vertex to get our axis of symmetry. In intercept form, we found the halfway point between our intercepts, and that was the axis of symmetry. In standard form, we use negative b over 2a. Negative b over 2a, that's the axis of symmetry and the x-coordinate of the vertex. In standard form, the y-intercept is just your c value. So whatever number you have hanging out there by itself, that's your y-intercept. So the point 0, c is also on the parabola. So when we graph quadratic functions in standard form, first we want to determine whether the parabola opens up or down. Find and draw the axis of symmetry. Remember, that is negative b over 2a. And then we're going to plot the vertex. You may say, well, how do we get the y value of the vertex? Well, if we know the axis of symmetry by using this negative b over 2a, and that gives you the x-coordinate of the vertex, we plug that into the function, the original function up here, to get the y-coordinate of the vertex. Then we're going to identify the y-intercept, which is at 0, c, and plot that on the graph. Now we're going to reflect the y-intercept plotted in step 4 over the axis of symmetry. So because a parabola, that graph, has symmetry along the axis of symmetry, if we count from our y-intercept to the axis of symmetry, we can count the same distance on the other side and plot their points. And then we draw a parabola through the plotted points. So let's see how that is graphed. So we have y equals negative x squared plus 6x minus 8. So the first thing we're going to do is list our ABCs. A is negative 1, B is 6, and C is negative 8. And since our A value is negative and there's a negative in front of x squared, that means we're going to open down. And it means we're going to have a maximum value that we're going to have to calculate. Well, axis of symmetry is x equals negative b over 2a. So x equals negative 6 over 2 times a, so 2 times negative 1, and that equals positive 3. So our axis of symmetry is x equals positive 3. Now to figure out the vertex, you're going to take 3. We're going to take 3, and we have to plug that in for each x in our original function. So we have negative 3 squared plus 6 times 3 minus 8. Now notice that the negative is outside of the parentheses that I wrote, and that's because I do not want to make the mistake of doing -3 times -3 or -3 in parentheses squared. Our a value is -1, and the x value we're plugging in is +3, so you have to do +3 squared first and then make it negative. So that's something that's very easy to mess up. So I just wanted to point that out. So when I plug that in, I get +1, which means our vertex is at 3, 1. What that also tells us is that our maximum value is at y equals 1. So remember, with our vertex, the minimum or maximum value is also the y-coordinate of the vertex. So let's go ahead and plot that, 3, 1. Our y-intercept is 0, -8. So that's our c value. So 1, 2, 6, 7, 8. Okay. So now we need to reflect that over the axis of symmetry. So let me draw in our axis of symmetry. And you see how we are 1, 2, 3 units away from the axis of symmetry. So we go 1, 2, 3 on the other side. And that's our point. Do not make this look like a V. This is a quadratic function, so your graph needs to look like a parabola, not a V. Your domain, well, your domain for a quadratic is always -infinity, infinity, and the range, since everything is going down, downward arrows, our y value go all the way to -infinity, 1, our highest y value. And then for end behavior, as x approaches -infinity, that means the left side, y approaches -infinity as well. And the right side is also going down. Remember, for quadratics, these two should match on your end behaviors. So both sides are going down. Now this one is written in intercept form, and I know we're talking about standard form today, but I thought it'd be good practice to get an intercept one in here as well. So since I know this is a quadratic, the domain -infinity, infinity, I don't know anything else until I really graph this. So what I'm going to do is graph our intercepts here. And we have one at -3, 0 and +1, 0. So we could write that down. -3, 0 and 1, 0. Now the axis of symmetry will be halfway in between those. So if we look, we have 1, 2, 3, 4 units in between them. So the axis of symmetry will be right between them, halfway. And that is at x value of -1. So my axis of symmetry is x equals -1. So now I can plug that in to the original function to figure out the y-coordinate of the vertex. So 2 times -1 plus 3 times -1 minus 1. And when I type that into the calculator, I get -8. Now what we can do is write our vertex as -1, -8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. And then we can draw our parabola. Oh, that helps us with the range now. our range, our smallest y value is here at -8, comma, infinity. Oh, y-intercept. So let's think about that for a minute. This is not an intercept form, so how can we find the y-intercept? Well, up here, remember, the y-intercept is the y value when x is 0. So we could take 0 and plug it in for x up here in our function, and that will give us a y-intercept. Now you may say, well, I look at the graph and it looks like it's at -1, 2, 3, 4, 5, but when you can verify it mathematically, you always want to do that in case your picture is not very accurate. So I'm going to plug in 0 for x. So 2 times 0 plus 3 times 0 minus 1. And when I type that into the calculator, I get -6. So my picture was a little bit off. That means my y-intercept is 0, -6. So you can still find the y-intercept even if you're not in standard form. Now let's look at transformations. Your transformation is RST. And again, you may be saying, well, how do I get my RST when I'm not in vertex form? Our vertex is our h, k. And our h and k are the vertex values. So in this problem here, our h is -1. Our k is -8. And then our a value is right here, that 2 in front. A is 2. So we could rewrite this in vertex form. And that's how this quadratic would be written in vertex form. Remember, we have a and then x minus h. As this h is -1 here, it becomes +1, and then minus k. So now in this form, you can do your RST. There's no reflection. There is a vertical stretch by 2. Translation, our translation is left 1 and down 8. So don't think that just because you're not in standard form or in vertex form that you can't do a little bit of math to figure out what your y-intercept and what your transformation would be. So this was kind of a good problem for us to talk about because we went from intercept form, but we still found all the information we needed when it came to the y-intercept and our transformations. All right, so here's another one in standard form. And we're asked to find the vertex, axis of symmetry, domain, and range. And domain, we know, is going to be this. And let's then calculate the axis of symmetry. So that's x equals -b over 2a. So it's going to be x equals -8 over, because 8 is our b value, over 2 times -4, which is going to give us +1. So axis of symmetry is x equals 1. Then we can take that 1 and plug it in for x. So y equals -4 times 1 squared plus 8 times 1 plus 2. And just like with that first example, you want to be careful not to multiply by -4 first before squaring that +1, because you'll get a completely different answer than you should. So when I type that all into the calculator, I get y equals 6. So that means my vertex is 1, 6. Now, our y-intercept, I'm not asked for that specifically, but because this is in standard form, we do need to plot that y-intercept, which is going to be at 0, 2. And then the axis of symmetry is right through here. meaning we count 1 over to reach the axis of symmetry, and then 1 over here, and then this is our parabola. That makes our range -infinity, comma, +6, because that is our biggest y value. Well, transformations, again, that is the RST, and we could even take this standard form function and write it in vertex form. Y equals, our a value is -4, x minus h, well, h is the x coordinate of the vertex, so -1 squared, plus k. Our k value is the y coordinate of the vertex, which is 6. So now that we have our vertex form, we could write the RST. Because a is negative, there is a reflection over the x-axis. Shrink or stretcher is a vertical stretch by 4. Translation, we are translated right 1 and up 6. So again, we were able to go from standard form to vertex form because we were able to get our a value, and we have our vertex here, and that allowed us to write it in the separate form, and that allowed us to get our transformations. Let's look down here. So this is going to be a change of pace for a little bit. Instead of us graphing the function, we're going to look at a graph, and we have all 3 forms of the graph. We have intercept form, we have our standard form, and we have vertex form. And we're going to use that to answer these questions without really doing any more math. Domain is always -infinity, comma, infinity. Now, when it comes to our range, this quadratic or parabola opens upward. So we want the minimum value. The minimum value is the y coordinate of the vertex, which we use equation number 3. So the range will be -32, comma, infinity. Our vertex can be found from equation 3, and it is +1, comma, -32. In what equation did you see the vertex? That was number 3. Our axis of symmetry, that is the x coordinate of the vertex, so that'll be x equals 1. Then in what equation can you see the axis of symmetry without solving? That was also number 3. How can you solve for the axis of symmetry in other forms, especially in number 2? Well, the axis of symmetry we learned today is x equals -b over 2a if we are in standard form, which is what number 2 is. If we were in form 1, intercept form, you would just find the halfway between the intercepts. So, or halfway between x intercepts. Our x intercepts, according to equation number 1, we look and see which makes both of these 0. So in the first one, it'd be x equals 5, and the second would be x equals -3. So those are the 2 x-intercepts. We will have -3, comma 0, and 5, comma 0. And we got that from equation number 1. The y-intercept was 0, comma 30, and we get that from equation number 2, because we have -30 all by itself here. Oops, 0, -30. and that was equation number 2. Min or max? Well, this is a minimum value, and it was y equals negative 32, and that was by looking at our vertex up here. And our vertex is equation number 3. And then the end behavior. As x approaches negative infinity and as x approaches positive infinity, both sides of this function, the left side is going up and the right side is going up. So y approaches positive infinity on both sides. So this problem here is a good exercise on which information is easiest to find depending on the form our quadratic is in. So we're going to be practicing this a little bit more because it is such a powerful tool to be able to use. Because sometimes it might be easier to use one form or another depending on what the question is asking for. So I hope that this was a good introduction. Make sure you like and subscribe to the video.